How's it going, everyone? So today I'm just going to we're going to talk about how to draw a Lewis dot diagram or a Lewis dot structure, electron dot diagram. There's a lot of ways to say this. So basically, this is very similar to a Bohr model, except very importantly, we are only looking at valence electrons. And a valence electron is any electron that is located in the most outer energy level of the atom. So hopefully you read about this yesterday after your test. But if we take a look at this beryllium atom right here, how many valence electrons would it have? It has 4 in all electrons. It would have 1, 2 on the outside. So now let's make a beryllium model. So we're going to start with the element symbol, Be. You can always use your periodic table to help you with that one. Next, we need to figure out how many valence electrons the element is going to have, which in this case, if we're looking over here, I see 2 on the outer level. Next, it says add the valence electrons around the symbol. Use the box shape. So if you take a look right here, if you were right up in kind of that way, you can see this is the order in which we're going to fill out our Bohr models. Basically, we want to make sure the electrons are spaced out as properly as possible. Electrons are negative, and negative, they want to repel each other. So when I'm drawing 2, I don't want them next to each other. I'm going to put them in 2 different spots. So there's one, and there's another. So there is my Lewis dot structure for beryllium. Pretty easy. Now, if we move down, we have something called the rule of 8. And this basically means the maximum number of valence electrons we can have in an atom is 8. So any more than 8, you will know that you have too many. Another word for that is called the octet rule, oct meaning 8. We won't have any more than 8 in that outer energy level. So we're just going to do one quick practice problem. So if you take a look here, let me move my screen, there you go. There's a couple practices. This is what it would look like if there were 8. This is what it would look like if there were 5. Should be pretty easy. But just for fun, we're going to pull an element from the periodic table here. So I'm going to zoom in. So if we were doing, let's say, oxygen, we're not going to draw the Bohr model. We've had plenty of experience with that. There's my symbol, the O. And all we need to do, and here's a little trick for you guys, at least for the first 3 rows of the periodic table. This isn't necessarily going to always work, but if you take a look at my cursor right here, you can actually count how many valence electrons there are going to be each time. So we have 2 here that are going to max out that inner level. So now we just count. Lithium would be 1, 2, 3, 4, 5, 6. There are 6 valence electrons. So now I just have to draw my diagram. 1, 2, 3, 4, 5, and 6. That is what my oxygen would look like. Thank you for listening, everyone. Have a great rest of your day.